You must have used one of these softwares at some point in your life, like chatbots such as ChatGPT and Gemini. We also have a AI generator image, which Gemini can do nowadays. We have stock price predictor, face detection system. You must have at least heard about it somewhere, right? Now imagining building one of these systems on your own and much more. By the end of this playlist, you won't just understand how these work. You'll build them from scratch on your own. This is complete zero to mastery roadmap for machine learning and AI. Most ML courses are too theoretical, but here we learn everything by working on many projects from small to big. When it comes to small, it can be something like spam filter, housing price prediction, something like that, which is very common. When it comes to big, it can be something like chatbot, building an AI image generator, or something like that. As soon as we move ahead, our project's complexity will automatically increase and we learn a lot more. So who are you? What are the prerequisites to learn this course? There are none. There is none. You don't need a PhD, you don't need a master's. All you need is a willingness to learn, willingness to fail, willingness to fix. That is all expected from you in this course. Now, before moving ahead, let's discuss about small things like what all we will cover in this course, right? So we will cover from classical ML, like something like linear models, regressions, clustering, classifications, something like this to give you an idea how machine learning is invented, how it works. But don't worry, we won't dive too much into theories. Actually, every algorithm we will learn is by working on one project or another. So don't worry. From that, we will slowly move ahead. And at the end of the day, we'll go to Gen AI, LLMs to build something like chatbots or image engines or video generation and something like that. So don't worry, we'll cover everything there is to learn in ML and AI, and we'll make it as much practical as possible. So just hang on tight. Now let's move ahead. So before starting further, let's talk about what machine learning is. Don't worry, we are not going into theory. We're just discussing a basic idea to give you some knowledge how machine learning, what the intuition behind machine learning. So do you know what are these images? Yeah, you obviously know, right? So this is a cat and this is a dog. But the question is, how do we know that this is a cat and this is a dog? Very simple. Someone must have told us in our childhood that this image belongs to cat, and anything that looks like this is a cat. So now what our brain will do subconsciously, it will say that if something has whiskers, something has eyes like this, something have ears like this, then this belongs to a cat. Same way, if something has this kind of an image, our brain will process this and will say, okay, this belongs to dog. Now, whenever a new image comes up, what do? We find a similarity between these learnings which we have already done in our childhood. We say how much similarity it has. So if we get a cat image and we see, okay, it has this much similarity, it has like 90% similarity, then we say, okay, it looks like cat. And if we say that it's 99% similarity of dog, then we say, okay, it looks like dog. So basically, what our brain is doing without us figuring out, without us doing any calculation, is it is trying to find some kind of similarity, some kind of relation from our existing learning. If you ask a kid who has not learned anything from its childhood, they won't be able to identify whether this is a cat or this is a dog, right? We must have learned this somewhere, and processes only that's why we can learn. Now, what does machine learning do? So now imagine you have all these images of cat, right? We feed all these images to computer. What computer does is computer finds a pattern between them. Computer see how each of these images look. It finds a relation. It finds the ear shape, whiskers, mouth, eyes, shape, and everything else. It finds each of these features and tell, okay, now I know what a cat looks like. Now what did we do? We taught computer what the actual meaning of cat is. Now what will happen? Now as soon as you feed the computer this image, what it will do? It will say, yeah, this is a cat. Why? Because this is very similar to what you have taught me. Versus, now if you feed the computer this image, dog, it will say, okay, I don't think this dog belongs to cat category. Why? Because whatever you have taught me, dog doesn't match with this. It matches with like 15% similarity or something like that. So we know that anything less than 50% is clearly a no. That means that is not a cat. That is a different species, which is a dog. This is just to give you an intuition how actually ML learns. It is a very simplified version of our brain. Our brain are able to learn things from few objects. Like if you see few cat images, you will be able to identify, okay, this one is a cat. Versus when it comes to ML, it's complex. You have to feed them hundreds, thousands, millions of images to identify it, to actually teach it. So in simple terms, you can think of machine learning as a dumb human who needs a lot of data to learn. Cool. So let's move ahead. Let's know about something that how machine learning is different from traditional algorithms. Like, what are the bigger changes you see from coding perspective? Okay. For example, let's say that sometime before someone build a spam filter. So what's spam? So if you use Gmail or any kind of other email criteria, what would happen is that whenever you get a reward offer or some kind of fraud alerts or bank messages, those are automatically go to spam, right? Because your computer automatically identifies that those are useless mails to you, and there is nothing you can do about it. And you don't want to read them. You don't want to occupy all your mail space. You don't want to occupy your reading space. So the computer directly filters that out. Now, traditionally, how was it used to build? So traditionally, what we used to do was, let's suppose you have an email. You have a lot of emails, let's say email one, email two, and you already know whether it's a spam or it's not a spam. Okay, imagine we have a lot of these emails. Now what we will do? We'll find out what are all the spam mails. Okay, we'll look for the keywords into them. Now keywords could be like for you, reward, or some kind of other random data. It can be any keyword. Now what will happen? You will feed these keywords into a pattern detection algorithm. Pattern detection algorithm. What this pattern detection algorithm will do is it will search for the keywords which you have found into new emails. So now what happens is you will run this pattern detection algorithm on new emails. New emails. And if this pattern detection algorithm is able to find the same keywords on the new email, you will output yes. Else, you will output no. That means no keyword find, so it's not a spam. If you find the same keyword as a spam previously, then you classify it as a spam. Now imagine that, let's just say that fraudsters will keep on improving, right? So they will keep on changing the keywords. They will keep on changing the text. For example, this for you could be replaced with something like, now this for you could be replaced with for you also as well, right? So now if the keyword is changed, then you will have to fed this keyword to the new pattern detection algorithm, now which will search for new keywords. And again, you have to do this for every single email. Now assume you have millions and billions of emails. So you can understand how cumbersome this process is, right? Although we can automate few of these processes, but still it's a lot cumbersome than ML. You will see how. Now let's see ML. What will ML do? So what ML does it will take all your emails, one, two, three, so on and so forth. It will take whether it's a spam or not a spam, spam or not a spam, spam or not a spam, something like this. Now it will, when you feed this data to your ML model, what it will do it will automatically find out that, okay, these are the keywords which I need. This is how I need to find whether something is spam or not spam. And what happens is it will give you an ML model. So basically you had an input X, which is nothing but this table, and you have a Y, which says whether an email is spam or not spam. So you already had these details. Now what happens? You will feed, you give this input, and you find an ML model which works on it. Now what happens? Whenever you find a new email, let's say a new email comes up, you will use this ML model on it and say, And this ML model will find out whether it's a spam or not spam. Not spam. From this itself, you can see that how much easier it is to compute the result compared to this. Whether you're looking for keywords, searching for keywords, and creating a pattern detection algorithm, and running it on new emails. Now everything can be simply done by finding an ML model. That's the difference between a traditional algorithms versus the new ML models. Now that's enough of a theory. See you in the next class. Bye.